Introduction. In the previous video, we looked at power distribution networks. As electronic devices become smaller, faster, and more complex, ensuring stable and reliable power delivery is more important than ever. This is where power integrity analysis plays a critical role. What is power integrity analysis? Power integrity analysis is the process of examining a circuit's power distribution network, or PDN, to ensure stable power delivery. It identifies issues like voltage drops, noise, and electromagnetic interference that can impact performance. Why is power integrity analysis important? Power integrity analysis is vital because it prevents voltage drops, reduces noise, enhances reliability, optimizes performance, and ensures compliance with regulatory standards. Steps in power integrity analysis. PDN modeling. The first step is creating a model of the PDN, including planes, traces, vias, and capacitors, while accounting for resistive, inductive, and capacitive effects. Voltage drop analysis. Analyze resistive losses to ensure dot voltage at critical components remains stable, even under peak load conditions. Noise and ripple analysis. Measure transient noise and ripple caused by switching currents, ensuring clean power delivery to sensitive components. Impedance analysis. Analyze PDN impedance over a wide frequency range and maintain low impedance to suppress noise effectively. Decoupling capacitor optimization. Evaluate and place capacitors strategically to minimize noise across a wide frequency range. Power plane resonance analysis. Identify resonances in power planes and mitigate them using proper shapes and damping techniques. Thermal analysis. Ensure efficient heat dissipation by optimizing trace widths, via counts, and copper thickness. Tools for power integrity analysis. Power integrity analysis relies on advanced simulation tools, measurement equipment, and EMI/EMC testing tools. Common challenges in power integrity analysis. Challenges include handling high-speed designs, compact circuits, wide frequency noise, and thermal constraints. Best practices for power integrity analysis. To ensure success, start power integrity analysis early. Optimize the PDN, use simulation tools, validate with testing, and iterate for continuous improvement. Power integrity analysis is the foundation of reliable and high-performance electronics. By mastering it, engineers can design systems that meet the demands of modern technology. In the next video, we'll explore high-speed signals in detail. Thank you for watching, and stay tuned for more in our Back to Basics series.